Assalamualaikum class. In this video we are going to start exercise 1.6 quadratic equations and its application. So at first we will discuss that what is meant by a quadratic equation. A quadratic equation is basically an equation in which maximum power of the variable is 2. As we have discussed that in case of linear equation the maximum power of the variable is 1, but for quadratic the maximum power of the variable is 2, and the standard form of quadratic equation is ax square plus bx plus c is equal to 0, where a, b and c are constant terms along with the condition that a is not equal to 0. And why we are imposing the condition that a must be non-zero? Because if a is equal to 0, it means it will no more a quadratic equation, it will become a linear equation. That's why we have imposed the condition that a must be non-zero over here. Now for solving a quadratic equation, that is to find out the value of the x in such case which is going to satisfy the equation, there are four methods to solve quadratic equation. The first one is named as factorization or factoring. The number two is using the square root property, then by completing square method, and by using quadratic formula. So we will discuss the methods one by one. So at first we are going to discuss about the factorization or the factoring method, in which we must know how to factorize a given expression and then we will solve the equation further. So here we are having question number 2 first, in which we have to use factorization method or factoring method to solve quadratic equation. So the equation is given 2y square plus 5y is equal to 3. So at first we must have 0 on the right hand side, so we will shift 3 on the left hand side. So 2y square plus 5y minus 3 is equal to 0. Now we will factorize this expression, that is we have to perform midterm breaking over here. So for the midterm breaking, what we will do, we will multiply the first coefficient with the last coefficient, that is 2 into minus 3, which is minus 6. Now we will find out the factors of minus 6, whose sum or difference is going to be the middle term, which is basically 5. Now we know that minus 6, for minus 6 the factors are minus 2 and plus 3, 2 and minus 3, 6 and minus 1, minus 6 and plus 1. All these are the factors of minus 6, or their product is going to be equal to minus 6. But now we have to choose wisely the middle term or the factorization, so that the middle term is recovered by addition. So clearly plus 6 and minus 1 will be the factors, because their product is minus 6 and their addition is going to be plus 5, which is a middle term. So this is how we can break our midterm in the 6 and minus 1 factors. So 2y square plus 6y minus 5, we are replacing this plus 5 with 6 and minus 1, minus 3 is equal to 0. So 2y, we will take 2y common from these two factors, we are left with y minus y plus 3, and then we will take minus 1 common from these two factors, and here are the resultant, that is y plus 3 into 2y minus 1 is equal to 0. Now the product of any two terms will be 0 if and only if any one of the terms is 0. So we will put y plus 3 is equal to 0, that is minus 3, and then 2y minus 1 is equal to 0, that is 1 by 2. So these are the two zeros or the solutions of the given quadratic equation. Next we have question number 4. 3s square is equal to minus 6. One thing is really very important over here, that you can cut 3 and minus 6, so you can divide 3 on both sides, so that we are left with s square is equal to minus 2s. But you cannot cancel out this s with this s, because this is not possible. If you are cancelling out the variable, or basically you are dividing the equation with the variable, it means you are imposing the condition that s is not equal to 0 by yourself, but you cannot impose any condition on the variable. So that's why we cannot cancel out the variable on either side of the equation, so we have to solve it with the help of factorization. So for factorization we must have 0 on the right hand side. So 3s square plus 6s is equal to 0, we will take 3s common, so we are left with s into s plus 2. So s will be equal to 0, or s plus 2 will be 0, that is 0 and minus 2 will be the two roots or solution of the given equation. Next we have question number 6. 16x square plus 9 is equal to 24x. So we must have 0 on the right hand side, we will shift this 24 on the left hand side. So this is the general form of the standard form of the quadratic equation. Now for the midterm breaking, we will put 16, multiply 16 and plus 9, which is 144, and the factors of 144, which is going to make minus 24, are minus 12 and minus 12. So by taking common, we are left with 4x minus 3 into 4x minus 3, that is x is equal to 3 by 4, and 3 by 4 there may be a possibility of having the repeated roots, so it's okay. The next method is by using square root property. So in this method we only use the square root, or we will apply the square root on both sides of the equation. So here we are given with the question number 8, n square plus 16 is equal to 0. So at first we will shift this number on the right hand side. that is n square is equal to minus 16. Now we will take square root on both sides, so this n square root is going to be n, and this minus 16 is going to be 4 iota plus minus 4 iota, because we cannot have a negative number in the square root, because if we have negative in the square root it corresponds to iota term. So the next question is question number 10. D square minus 36 is equal to 0, that is d square is equal to 36. Again taking square root on both sides, d will be equal to plus minus 6. Then we have question number 12. N square minus 25 is equal to 0, that is x square is equal to 25 over 9. Now by taking the square root we are left with x is equal to plus minus 5 by 3, because the square root of 25 is 5 and square root of 9 is 3. Then we have question number 14. 16 w square plus 27 is equal to 0. Now mega square of the w square is equal to minus 27 over 16 by taking square root, because we are having negative term in the square root, so we must have iota over here plus minus, and square root of 16 will be equal to 4, and for square root of 27 we may use calculator, or you can solve it by your own. That is 27. The prime factorization of 27 is 3 into 3 into 3. This 3 square will be taken out of the square root, so we are left with 3 square root of 3, because I can write 3 square root of 27 as a square root of 3 square into 3. So this will cancel out the effect and the square root will only left with 3. So 3 square root of 3 over 4, or you may use calculator for computing square root of 27. Next we have question number 16. T minus 2 whole square is equal to minus d. Simply taking square root on both sides, we are left with t minus 2 is equal to plus minus square root of 3 iota, and because of this negative sign we are having iota over here, and we can shift 2 again on the right hand side. So 2 plus minus square root of 3 iota. Then we have question number 18. M plus 4 whole square is equal to 1. So taking square root on both sides, m plus 4 is equal to plus minus 1, and then we can shift this 4 on the right hand side. So minus 4 plus minus 1, that is minus 4 plus 1 minus 3, minus 4 minus 1 is minus 5, are the two roots of the given equation. The next method is named as completing square method, and in completing square method we have to complete the square of the expression, and we know that the complete square or the perfect square formulas are 2, that is a plus b whole square is equal to a square plus b square plus 2ab, and a minus b whole square is equal to a square plus b square minus 2ab. So you can see that we the only difference is of this plus and minus 2ab term. So when we want to, what is meant by completing square method, that we have to complete this square or these terms depending on the sign of the coefficient of x. So if we are given with x square plus 4x plus 2 and we have to make the square complete, so right now it is not a perfect square, but we can make it to be a complete square. And how we can do it, that you can see that we can compare the term with a square plus 2ab, because this can be replaced with a, and this is going to be deal with 2ab because x is named as a. So when I'm going to compare the two expressions, x will be equal to a and 4x is equal to 2ab. A is equal to x, this x and x will be cancelled out, and b will be equal to 4 by 2, which is equal to 2. So whenever we have to find out the second term or the b term, we have to divide the coefficient of x by 2 so that we are able to find out b. And why we divide it by 2 always? Because of this formula expression, because in formula we have 2ab. When we make the coefficient of x square 1, we can name x to be a, because a square and x square can be compared easily. And then for the term b, we are going to compare the two term, the coefficient of x or the x term with 2ab, and this 2 will divide the coefficient of x in order to get the value of b. So this is a well defined method for the completing square method. And number 1, make the coefficient of x square 1 and then divide the coefficient of x by 2 to get the value of b, and then add and subtract the square of b. So you can see x square plus 4x plus 4 is going to be x plus 2 whole square, and we will deal the other two terms or the other two constant with and we are left with minus 2. So this is how we can complete the square of any term or any quadratic term. So here we have question number 28, in which we have to apply the completing square method. So y square plus 4y minus 3 is equal to 0. The coefficient of y square is already 1. So for the value of b, we will divide the coefficient of y by 2. So we are left with 2. And for making the square complete, we are going to add and subtract the square of b, that is 4, in the expression. So y square plus 4y plus 4 and minus 3 and minus 4 will be dealt simultaneously, which is minus 7. Now this is going to be y plus 2 whole square is equal to 7. Now taking square root on both sides, here is the final result. Then we have question number 30, 2s square minus 6s plus 7 is equal to 0. Here you can see that the coefficient of x square is equal to 2, which is not equal to 1. So we will make it 1 by dividing the whole equation with 2. So we are left with s square minus 3s plus 7 by 2 is equal to 0. Then we will divide the coefficient of s by 2 in order to get the value of b, which is 3 by 2. And then we are going to add and subtract the square of b, that is 9 by 4. Now this s square minus 3s plus 9 by 4 will make the perfect square, and we are shifting the other two constant terms on the right hand side, and by taking the LCM we are left with minus 5 by 4. And then we will take the square root on both sides of the equation, and here is the final result, which is 3 by 2 plus minus the square root of 5 iota over 2. Then we have question number 32, 4v square plus 16v plus 23 is equal to 0. Clearly the coefficient of v square is not 1, and we can make it 1 by dividing the whole equation by 4. So y square plus v square plus 4v plus 23 by 4. And then for the value of b, we will divide the coefficient of v by 2, which is 2, and we will add and subtract the square of 2, that is 4, in the equation. Now y square plus 4v plus 4 will make the perfect square, and this minus 4 and 23 by 4 could be shifted on the right hand side, and by taking the LCM we are left with minus 7 by 4. Then taking the square root, here is a final result, minus 2 plus minus square root of 7 by 2 iota. Next we have question number 34, 3z square minus 8z plus 1 is equal to 0. Again we will make the coefficient of z square 1 by dividing the whole equation by 3. So here we are left with z square minus 8 by 3 z plus 1 by 3. And then for the value of b, we will divide the coefficient of z by 2, that is 4 by 3, and we will add and subtract the square of 4 by 3 in the equation. Again z minus 4 by 3 whole square is equal to 13 by 9. Taking square root on both sides, we are left with 4 by 3 plus minus the square root of 13 by 3. We are familiar with the standard form of the quadratic equation, which is ax square plus bx plus c is equal to 0, with a not equal to 0. So now we are going to apply the completing square method on this standard form of quadratic equation. So clearly the coefficient of x square is not 1, and we will make it 1 by dividing the whole equation by a. So we are left with x square plus b over ax plus c over a is equal to 0. Now to find out the value of the second component, or the b, we will divide the coefficient of x by 2. So we are left with b over a divided by 2, that is into 1 by 2, so b over 2a, and we will add the square and subtract the square of this term, that is b square over 4a square, in the equation. Now x square plus b over ax plus b square over 4a square is going to make the perfect square of x plus b over 2a, and we will shift the other two terms on the right hand side, and by taking the LCM we have b square minus 4ac over 4a square. Now we will take the square root on both sides of the equation, that is x is equal to b over 2a is equal to plus minus square root of b square minus 4ac over 2a, because the square root of 4a square is 2a. And then we will shift this term on the right hand side, and minus b plus minus square root of b square minus 4ac over 2a. This is named as quadratic formula, and quadratic formula is the method which could be applicable on any form of the quadratic equation.